So this meeting will be recorded and we are also live on YouTube. So if you ever want to go back and uh, review that, you could always do that. Hello, everyone. Yeah, so let's get started. I'm sorry for the delay in this. There was some kind of a problem in coordinating the Zoom link. I think there was a wrong Zoom link that was put in, but yeah, hopefully everyone is in. And I've also addressed uh, all of the other questions. Let me go ahead and start the event. So there is a small survey in this call. I'll go ahead and present that survey to you guys. Just you can fill it up. It's like 4 or 5 question survey just to gauge the experience of our attendees, like who is attending, and so that uh, we know how to answer questions, or at least to learn about your background would be good. Let me go ahead and share my screen. Hopefully everyone can see my screen. So let's get started with our presentation. Hopefully, everyone is. We will be discussing today about vision language models. I'm just presuming like all of you are aware of large language models, the models that we are used to. So today we're going to talk about how these models evolved from a decade ago, and how they are now. So we'll be going a bit technical in the sense that we'll be discussing about their architectures, and we'll also go through some demo that we could probably run these models locally. So if you have Olama, you could probably run some of these vision language models locally as well. So we'll go through that session maybe after the initial hour. We'll have 1 hour for a Q&A and also some practical hands-on sessions that we could do locally. If you have any problems, you can always put that in the chat while you're working on that. And I want this to be more of a engagement where we all there's back and forth. Uh, we can discuss a lot of these. Any questions that you have, you could always put in your chat. If you want to discuss any of your current projects, or maybe it's something that you're already working on, you can definitely share in the chat, in group chat. So if you want to give a quick intro on who you are and your interest in attending this event, it would be great. So that you could also network through chats. So it's just not a one-man show. So it's a community where we all share knowledge. So if you feel like you could answer a question in the chat, please feel free to do so. And if you have any questions, please post it in the chat as well. I will interrupt the presentation, and then we can go ahead and review those questions. So let's get started with vision language models and why do we use them, and how those are different from other models, which are large language models that most of you might have already been used to. This would be a fairly technical presentation, so there might be some technical terminologies in terms of going through the model architecture, or even understanding how things were done long back and how things are being done now. So if you don't have any prior knowledge, in CNNs or even the current vision transformers, not a problem. You can always listen in and just understand how these models are trained and built, and how they are able to understand the world by mapping language and images together. So let's go ahead with the quick evolution of large of computer vision, right? So computer vision has been a domain that many researchers have been working on for a very long time. If you see CNNs from 2012 to 2020, there are a lot of computer vision solutions, a lot of data sets, and also model architectures that evolved. They call it computer vision models. There was no terminology called vision language models then. It just came out maybe 5-6 years ago by different innovations from Google and other big research labs. But given these computer vision, they are pretty limited in the sense that the computer vision models then were fine-tuned for a specific task. They cannot be generalized. So generalization is something that lacked. These models didn't know how to go ahead and do proper reasoning on the images. If you want to train them on new data, you probably need to get a data set and then train ResNet on that new data set. So ResNet is the architecture. It's a deep CNN with residual connections, the state of the art on ImageNet. ImageNet is a combination of millions of images that are used to train various deep neural network architectures. So 2016 to 2019, there are CNNs which scaled. There's EfficientNet. They just made that even deeper as the hardware evolved, the GPUs evolved, and also the model architectures evolved. Eventually, in 2020, there is something called vision transformer. We'll go in a bit more deeper into them in the coming slides, but we just want to give you how computer vision evolved over a decade. So they have vision transformers, just like regular transformers, which were able to do self-attention. Self-attention is something that came out in 2017 in a paper called "Attention is All You Need." In the way that how language has different words and how self-attention is calculated for every word within a sentence. Same thing happens in the image world as well. From 2021 to 2025 till now, so there are a lot of different architectures for vision transformers. We are seeing like hybrid architectures, the different backbones that are created and different segmentation and multimodal tasks. Those are all evolved in the recent times, in the last 4 to 5 years. So you could see this diagram here. It's all made by, I think I've used Gemini to make this. It did really good job, but there might be some typos here and there. So please do excuse that. So in 2019, I have, this is when I was working as a researcher doing research in computer vision. The deep light research paper, I was able to get a lot of train this computer vision model by gathering a lot of house images for different ages. So basically treated that as a supervised supervision problem. And then I was able to use ResNet to create a model that can predict age of the house by doing different categorizations of it, by doing different classes, and also did a regression to find out the accurate age of the house. So what I observed was there are a lot of features that computer vision it was able to learn various patterns in all these houses, but it was not able to generalize in new data sets. So in 2019, 2020, everyone expected there would be different models to doing different computer vision tasks. Maybe a model to do, predict the age of the house, or maybe some models to just detect some in the biomedical field, maybe some cancers, but only has to be trained on those cancers. So that requires a lot of data. But then comes the generalization phase. The transformers, the beauty of transformers is they can be scalable and they can be generalized. So they can be applied across different domains and different tasks. So that's the beauty of the transformer architecture. So that's the reason why in 2020, with introduction of the visual transformers by Google, there are There are a lot of different research work that built with vision transformer as a backbone. So most of these vision language models are actually using vision transformer on the hood. And how they work, we know the regular transformers, they treat every word, and they calculate self-attention for each and every word within a sentence. But how we do that with the vision space, that is an image. So they're able to do that using patches. So given an image, they break down the image into small patches, and those small patches would be used to create the embeddings that could be used to train a transformer encoder. And that itself can be used as a vision encoder where you give an image, the image is end of the day, it transformed into embeddings. But it is just a symbol, each and every patch is embeddings are created for every patch. Just like given a paragraph, how every word within that paragraph or in the sentence, each and every word or a token is embeddings are created for every token. Similar way, this image is treated somewhat similar, but we are basically using patches instead of different words in the language space. So that is how the vision transformers were able to understand or even map or encode images into high level visual embedding space that can be later on used to like build other models. So this is the work from Google. They initially did that to basically do classification of different images. It could be a dog or a cat, this kind of classification. And it's definitely a lot of innovation at that point of time in 2020. And then comes the clip. So clip from OpenAI, this really changed the game in the sense that they were able to prove that their architecture was able to beat ResNet and was able to outperform all of the previous architectures by using a vision encoder. So it's built on vision transformer, and they were able to do contrastive pre-training. So what they do is they trained a text encoder and an image encoder, and they try to calculate how similar they're able to project language space and also image space into the similar vector, higher dimensional vector space, and they were able to separate out things which are not similar. So if you see it's a Aussie puppy and the image of it, they are kind of nearby in the high dimensional vector space, and things which doesn't match are just put far away in the multidimensional image vector embedding space. So that's what CLIP means. It's a contrastive learning. So it learns from picture, and also it does build the mapping between the language and the text. It has two encoders, so both work in parallel. One being, it could be a CNN or a vision transformer, and other one for the text, which is a transformer, as we all know, because most of the large language models are actually built on transformers. It's the T that is in GPT. And so there are some fundamentals that we need to know, like how these vision language models work. Most of these vision language models, they take multiple inputs. Like you could give text, image, or even video as an input. There's some models now, they're actually taking videos too. And the vision language model would produce an output for those that different kind of data. And this output could either be describing the photo, it could be image captioning, it could also be visual Q&A, giving a image and asking what's on the table, or even multimodal RAG, where it is actually retrieving some data by finding similar, by comparing text with the multimodal data and matching them. So, and that really helps in retrieving images. It's the same thing that's working in your iPhone, like when you're searching for maybe, a dog or a cat in your iPhone, it probably retrieves even your pictures from your Photos app, right? Because it's all because of this multimodal retrieval that's happening within it. So this is how VLMs work. And, we also have a separate session for multimodal retrieval. It's happening next week. So you could always attend that to understand a bit more about, how we can build multimodal RAG using this kind of vision language models. And there are some core components like you should So we know that vision transformers are an example. They are one of the type of encoders that can encode or that can transform given image into numbers. And clip is something that uses vision transformer, and then it able to build this contrastive learning where it's able to learn images and the text pair that describe that image in the similar high dimensional space where they're able to map it. And now in but the vision language model, when you're asking a question, it is able to learn that by using a vision encoder, and then it is projecting that learned the learned image representation into the language space. So there's an adapter that connects both together, the vision world and the language world, and that happens through something called adapters, a different kind of adapters that learn. So that is one of the ways in which these different VLMs possess. Like it has a vision encoder, they have different adapters, and it also have a language model that it's basically mapping the visions to. So you don't have to train everything from scratch. Even if there could be a language model that is just trained on text, and you have a vision model that is only text, that is only trained on images, you could basically create a connection between them by having a adapter or a projector that projects images into the language space, and that way you are able to grab more information. You're able to do robust reasoning, because you don't have to train all of these models from scratch. Rather, we're building these on things which are independently trained for almost like last 10 to 15 years, right? Almost 10 years. So that's where ResNet and of this comes into picture, right? So vision transformers and the language model, given a language model, they all are connected together in the using different kind of architectures. There's Q-form or linear layers. These are different kind of ways in which the vision vision tokens and the language tokens are mapped, and they learn together. And there are different kind of adapters that are there. So adapters are just this part of it, and there are different types of it. So one is an early fusion. So it means that you're just combining the image and the text. You're just mapping them. You're creating embeddings for them and just concatenating them. You're just joining them, and now you're feeding that into a model. So that way, it's just the raw features that it learns. And it's usually large because now you have a huge vector that goes into the model. So it has to have a robust and a bigger, a huge, it has a huge model with a lot of resources to learn this. So, and that's the reason why it has high compute that you can see here. And there's also late fusion, in which both of them are not concatenated early on, but that does that in the end. But individually, they are both independently encoded using the image model and the text model, and then there will be a decision layer that actually classifies and that's able to later on understand how these both are related in the higher dimensional vector space. And there's one more adapter called the cross intention. So in cross intention, each basically they are encoded separately, then one attends to the other. So it's just like how in self-attention you have every word that attends to all the previous words. You have the similar pattern, but in this case, the text tokens attend to the image patch embeddings. That way, with cross attention, you're able to do more fine-grained mix-up of these embeddings, and you're able to extract fine-grained details from an image. So you can even describe the red ball, and you just get the specific region. So segmentation is something that people probably do with this because of this cross attention. Early fusion and late fusion, you could still do that, but the problem is there is not much extraction. There's not much granular details that you can grab. So these adapters should be somewhat created in a way that there's a trade-offs too. Like late fusion, you do have you probably need to have less compute resources, but later on you not get proper granular details that you can extract. Whereas cross attention, you can actually get those details really well. So you could see this just high level diagram. There are a few things which are just showing how the flow of information is. And the same thing even applies for even your RAG. So when you're doing RAG, how the similarity search that happens, how you're mapping image and text. There are also different kind of strategies, different kind of adapters that you can choose from, which is early interaction, late interaction, or cross attention. Um, Bridging all of these. So in 2022, 2023, now you get, as we discussed, different patterns, different adapters that evolved into different models. So Blip is one of the models that uses querying transformer. It's actually extracting different informations from a frozen vision encoder and then using and sending that to a frozen LLM. So that way it is able to map both the features together. Flamingo is also one thing that's from Google. It also it's from DeepMind. So they come up with this perceiver resampler. I'm not going too deep into them, but these are also different adapters that are just connecting the image world into the text world so that we create these vision language models. So even the Lava is something that we could anyone can actually create that or even run that in your local machine by using Olama that we're going to do pretty soon. But here also same thing happens. It actually uses clip based model with with Vision Transformer, and it's able to project that into Vicuna, which is a LLM, a small language model. That way, it's able to perform. It's able to do the multimodal interpretation of any image. So there are some things which are happening just now, like from 2024 to 25. You can see bigger models. These are all these models that we discuss here. These are all like open source. These are small models, but these are bigger models which are from some closed and some open source models. DeepSeek VL2 is really great in terms of it's able to understand language and also images. And you could see there's mixture of experts. MOE is mixture of experts transformer. So mixture of experts is you're basically dividing a lot of feed-forward networks into different small experts, and you're able to train it that way. During inference, you're not spending a lot of resources to do the inference. You only have few subset of your model weights that you can use for inference. So it's a great optimization. And you see most of these models now, they come with mixture of experts. So it's a special kind of architecture that we're going to use for different multimodal interactions. So now you're giving input as text, division, audio, everything, and you're able to build them with native support. And you're going to see Gemini 2.5 is also supporting 1 million tokens and 3 hours of videos. So how does videos work, right? We did discuss about images, but how does video work? So we have a different aspects that we consider in terms of videos. Videos are repeated images, right? They're just images that are changing dynamically with time. So there are different architectures that we discuss here and how the videos work. But yeah, they do support videos too. Qwen 2.5 VL is also from Alibaba. Qwen is doing really great with this. They do provide a lot of these small models that can run on, probably with 10 or 15 GB of VRAM, but they can process videos too. And Qwen 2.5 VL has different variations. They have 3 billion parameter models, 7 billion, and also some weights are bigger than that, depending on the hardware that's available for you. You could run. And even intern VL is also something that a recent model that uses native multimodal pre-training, and it does it just uses 448 by 448 patches to do that multimodal analysis. There are a lot of open source versus commercial, small models. They're less than 8 billion. There are a lot of models which does provide better output when compared with a bigger model, because smaller models can be fine-tuned. They can be fine-tuned on a given set of images, and they also require less memory and less resources. So you would see most of these models end up in edge environments now, Apple or Android. Recently, I think Android is Google came up with Gemma models, which are really small, lightweight models that can sit within your phone and just scan the world and analyze the world. And you could also see same thing with Meta, where Meta could actually see anything and explain stuff. So it's all happening through the small models which are deployed on device and which are trained in a similar way by mapping the text and the image space. So these are some of the lightweight models that you could all experiment with, and that you could run right away from your machine. So SmolVLM is an open source model that has very mediocre weight, like just 256 million parameters is very small, 500 million, 2.2. So it all depends on your hardware, and also the bigger the model, better this analysis. So smaller models can hallucinate, or they're not really that great at providing the reasoning behind a given image. So MiniCPM is also a different model. It got 8 billion parameters. Qwen 2.5 is from Alibaba, as we discussed. It does have better object localization. It does long document parsing. So document parsing is OCR. Like, you could use it for OCR, but the accuracy is not as good as regular OCR, but you can make it better you could at least it can analyze text in a given in an image and understand what's said. And you can also do long video comprehension. So you give a YouTube video and ask it to summarize. It does that in a very fast in a really fast time, and they use dynamic resolution. I think the model itself learn how to do sampling and all. So that's a beauty of Qwen 2.5 recently, it's a Qwen 3 that came out like a couple of weeks ago. But I think Alibaba is doing great with Qwen models. They also have a Qwen Omni model, which can take video, image, text, audio, everything, all the inputs. So it can take all the inputs, give an output in text or audio. So definitely you could check that out. We'll discuss those very soon. There are other open source models. You see, Gemma is actually from Google. They release the open sources. These are the models which are sitting within the Android phones. There's Gemma 3N models series, which are made for edge devices like mobile phone. Llama 3.2 is from Meta. There's Falcon and DeepSeek. Pixtral is actually from Mistral. And they have very good support for context length. They're 128K context length and edge deployment. So you could also deploy them in any of the edge devices as well. So if we could go ahead and start working on building and deploying some VLMs locally. So if you all have Ollama, we can start pulling a simple VLM and ask it to analyze a image. But before that, I know it was a really quick introduction because we could go over any of the questions that you have. But before that, let me tell you like how VLMs understand videos. So as we previously discussed, these vision language models, they can understand images, but the videos are series of images. So you could sample the images yourself from videos and then ask the VLM to just understand the image and give you an output. And you could do that for like multiple images within a video. And even OpenAI or Claude, they all say they analyze videos, but they don't do it natively. They only want an image, and the sampling is something that we have to do it to send them those images from the video. So the sampling is done from us, and they only do an image analysis and provide you an output. But there are some models which can actually support the native videos, like Gemma models support, and Alibaba Qwen models do support. So they do that by using videos and also add a different dimension. Previously, when we were trying to create the patches, we are basically doing the patches with height and width, but now you could also include a time component to it. That way you are also looking at the dynamic change of these patches over time and use that either to using 3D convolutions, temporal transformers. These are some transformers which does have self-attention across frames, but they're also taking care of the time component with it. Recurrent layers are also something that you can use to do like sequence modeling for over various frame embeddings as well. There's different pooling strategies. So sometimes you could use sample keyframes or average embeddings basically to do any kind of classification. And there is multimodal grounding as well. So there are some just like how Clip does with maps images with the text. We do have some models like which grounds video embeddings and they are aligned with the text as well. And Gemma 3N is actually trained using that kind of embeddings. So let's go ahead and do a simple hands-on session. I'm using Mac. If anyone has Windows, I think you could just install Olama and we can go through some models there. Okay. So someone posted a question here. So this video is recorded, but anyone has any questions or you guys want to just talk, you could please feel free to do so. And we do have ample amount of time because I was able to just do that in like 30 minutes or so. I can go over any of the other concepts that if you guys need me to explain again, I can do that. Yeah. So if you're a software developer and you want to build something with visual language models, I mean, you could always use an API to do that. There are a lot of cloud APIs that are available or, OpenAI APIs. But I recommend that if you want to build, because the biggest problem with is the latency. So when you're building something with cloud involved, you have to forward that image maybe to some servers. But with Gemma and also these smaller models, most of the hardware providers, even I don't know if Apple has any kind of APIs or SDKs to interact with their on-device models. They should have it. You could build something for the edge where the image doesn't have to go into the cloud, but rather you can build something only for that phone. Or if it is Android, then you could use Gemma 3N models to test out on the inference, maybe train it or fine tune it for different images and just work on it. I know it might not be the software engineering space for fine tuning models, but I think it's definitely with AI you could always step up and build for the edge, not just for the for the cloud. I think that if anyone wants to do that, I think it's a great or if anyone is already doing that, please do share your experience. But I think that's where things are heading now with VLMs. So because no one is comfortable uploading their images and getting inference on them, right? Because the biggest problem is the data loss. A lot of these images would probably end up in some cloud server, and with vibe coding and all, a lot of people releasing softwares which doesn't have proper security, and someone can just hack into the data and use the data. So if it is something happening on device, privacy is assured. RAM range to run smoothly. So there are different models. I'm currently using. Let me see what are the different RAM requirement to run a specific model. We could always Chat- uh, use ChatGPT or something to find out the exact RAM requirement for this. So I'm running um, a smaller model, which is, let me share. Share my screen. So 8 GB RAM, but when you're using a smaller version of it with Olama, you can get even any quantized version. So you probably need around like 5 to 7 GB of RAM to run this. And you also have a quantized version of it. So if you're using a Lava 7 billion parameters, you have a 4-bit quantized version of it. Let me share my screen and also show you guys yeah. So as of now, let me see. So if anyone want to install Olama, I don't know how many of you have Olama in your local machine, but if you do want to, work with this Olama, it's a very simple command to install it on Mac. But if you want to do it on Windows, you could find that. Um, I can probably post that. Or even if there's other Linux, it's even faster to do that. But yeah, Windows 10 and 11, these are some of the instructions that you can follow to install on Windows. Let me share this to you in the Slack in the chat group so that you can follow these instructions to install it on Windows. Um, let me see the model which I have. So I'm using just as Lava latest, it's 4.7 gigabytes in size. In terms of memory, probably I think it should probably take around 5 to 7 GB of memory to run. Let me go ahead and run. This is a simple doc picture which I'm asking you to describe, and there you go. Let's see what would be the description for this, but usually it should be yeah. So I just gave a simple dog image here uh, to describe. Um, in local. I don't know. I think maybe because of my simple dog image which I have. It's I think a lab that I have. I was able to download from internet previously. I don't know why it should be in my downloads only. Let me check here. I don't know why it's not showing up, but it should be in my downloads. So you could download some image from internet and just run one command, Olama run lava, and the installation should not take much time for you to run that. Or we can just download a new image and check for that. Um, So if you, there are some details which might not be 100% right because previously I gave it a lab and it was just saying it's a it's almost like because the output is different every time. So since it's being a small model, there's a high chance that it might just hallucinate. So this image that we just used, it's saying the image appears to be a low resolution photo of a dog. The dog seems to have short fur and it's facing the camera directly. It is not possible to determine any additional details of the dog as due to the low quality of the image. Okay, it's thinking the image quality is low and it's not able to detect all of it. But if you see, it was able to do proper reasoning, but most of the reasoning would probably be not be up to the mark because this being really small model. But you could fine tune that and create LoRa to if you want to build this model only to detect like different docs. Maybe you could just can fine tune it to make it better at it. And same thing goes with other models too. Like if you want to make it better at a different task, you can always get the data set and fine tune it on those. on the specific data sets. It could probably be, even if you're trying to classify any diseases, like you could even do that. Maybe the only thing is you need to have that data set and then fine tune it for that specific purpose. You also have a lot of unsloth notebooks if you want to follow along with the fine tuning for the VLMs. So let me share that as well. Yeah. This is a vision reinforcement learning. That's a recent set of models that came up, but they probably are using they're using reinforcement learning to fine tune it. But if you want to just use yeah, if you want to follow along this, you could do this. So now if you see here, these are the different models. Gemma 4 billion is actually from Google. And here they are basically fine tuning for different vision tasks. If you want to fine tune that, you could create different data sets. You have multiple data sets here. These data sets are open source, and you can follow along here. And the problem that they're trying to solve here is the radiography. So they're trying to see how to analyze a specific X-ray or CT scan. And there's some test data for, I think there's the radiography for some lesion. And since these models are not really good at this medical data sets, but still you can fine tune Llama 3.2 to be really good at this, to the specific image space. So you could just use this notebook, substitute the data set that you want, and start doing the fine tuning, and you can build loaders with it. So most of the models that we discuss now, those are all generalist models. So just out of, if you just want to go ahead and use it to solve a problem that you have, it may not work really well. You could always use your data set and then fine tune it using any of these notebooks. And then you can make it perform really well, even better than other frontier models like ChatGPT or models like GPT-4 series models, or even Claude Sonnet series models as well, because even Sonnet has some open source, some vision capabilities too. I'm sharing this to anyone who just want to go ahead and play around with this. Okay. So yes, I could go deeper into this. So basically, how it maps image encoding to text encoding. Just see, we did discuss few of the first thing is, in order to understand this, we know that as of now we are all built on some backbone, right? It could either be clip, or it could be using any kind of vision transformer. We use a vision encoder to begin with. So if you go through the slides, yeah. So during the training phase, you have a vision encoder and you have a language model. So if these are already, and we are starting with pre-trained ones, so we're not using anything from scratch. So whenever any VLM is trained, they are using some vision encoders which are pre-trained on maybe thousands of images, which already knows how to project them as different embeddings and create embeddings for these images. And you have language model. So during training, you're training this with two different strategies. Like you could either use cross attention, where you're having one layer, you're sending this data, and you have a cross attention layer where you are referring to you're having image and the text embeddings self attend to different modalities. So just like how you're training an LLM, when you train an LLM, what goes into this is the attention, right? Self attention is actually making this LLMs good at answering a question because of self attention. And here you have this cross attention with you are doing this across different domains. So a text embedding could refer to an image embedding. So you're mixing both of them together, projecting the cross attention between both the embedding spaces, and then you're training it. So when you're doing this training, you're basically mapping the higher dimensional vector space, and you're teaching the model on how to not just uh, you know talk the language, but also how to, and also capturing all the features of the image along with that word. So given a sun, so it does also know sun is how it looks like, right? And also if it is a dog, it does know how it is looks like, but also it maps dog with the text space. So this allows the model to be truly multimodal, where you could give an image input and a text input during and when you project that, or even when you run that through this different uh, layers, you could either inject or even project that embedding layers, image layers into a project that image embeddings into the text embedding space, and then train together. Or if you want to do that just independently, where you're just combining the output of embeddings from the image encoder and the output of text from the text encoder, and you just straight away just adding them together and now feeding that into a multimodal model and train that. And that network is just transformers. Okay, it's just you're not adding anything other than a regular transformer itself. But now you're just concatenating, so it's just not grabbing it's grabbing both the features and you're training it. So you just combine all of the raw features together. So in this case, the training would be pretty expensive because each embedding will be really huge. And since you're doing early concatenation, the model, the matrix multiplication, everything would probably be very costly throughout the model training process. But and also it's not too flexible as well, because when you're doing this, you're tightly coupling both the modalities together. And there is and you're doing the same thing. You're just training it with self-attention, but there's less flexibility because there are a lot of raw features that combine, and it does require a lot of heavy computation, and it's not really hard. It's very hard to scale. So these visual embeddings are patches, right? Every patch within the image is converted into embedding, and then you're just adding it to the language embedding. And in late fusion, you probably process image and text separately, and now you have and you use vision transformers, or you use transformers for text, and then in the output layer, you are just making that decision. You could either do that with averaging or concatenating in the output layers, and or just doing logistic regression over the final embedding space. So it's pretty simple because you're not doing any computation in the beginning, and your length of these embeddings will be very small because both of them are having independently do the encoding process. Only the last output is where you get into this analysis. But the problem here is you might not catch different fine grained details, right? Because both the embeddings are only interacting later in the process. So that's the reason why it's late fusion. So you might not capture fine grained interactions, but it's pretty simple to train. And cross attention is what we previously discussed, right? Even though you have this encodes separately, both of them at first, but they attend to each other. So basically, you're training them just like how you train an LLM, where every model, every embedding is attending to all of its previous embeddings, or all of its previous tokens. So you're basically you're having the text tokens attend to your image patch embeddings. So that's what you're doing. And also you're doing the same thing with image patch and the text tokens. And you're doing that from the beginning of this training process. And that's where you have this fine grain output that comes into picture. These are three different strategies, but usually most of them use cross attention. And these are something that previously there's few architectures that use this, but as I said, they're not that scalable. This is scalable, but you don't find you don't grab a lot of details. But this one isn't. Early fusion is highly computationally expensive because you're just concatenating and sending it to a transformers. But here, the cross attention really, most of the current models that are trained are through cross attention. And this is just the high level. If you ask me, okay, how every model is trained differently. If you see the Gemma 3N paper, maybe something called E4B, they use different kind of transformers. They use something called matformer. So matformer architecture is way different than the other transform. They use nested transformers. So in that case, they also have like they do the same thing. They have multiple embeddings for images and also for other text as well. But by using matformer, they're able to like create. They're basically nesting different layers of transformer, so they're able to do training for on image and the image space and also text space. So, but it is actually made for the edge. So these models actually support image, audio, video, text input. They do actually everything. So, and these are also trained for edge devices. So they also have like per layer embedding, basically to increase the efficiency on all of them. But yeah, they have a separate architecture while training how this multimodal embedding is trained, because the purpose of this model is to be deployed on edge. So they do this quantization of your training. They also have a different kind of transformer, and so that makes a difference. So not just this, even Qwen also is trained in a separate way. So if you see Qwen 12 training process. So let's see how this is trained. So it's basically using a visual phase for basic element understanding, a multimodal phase to connect images and text, and a long context phase to comprehend complex information sequences. They're doing that in a multi-stage process. So, but they are still doing that with a dedicated vision transformer encoder. And it just includes data, image captions. It does have, visual knowledge, OCR data. So these are all different kinds of data that they're using to train the vision transform, because we know the vision transformer is the basis for all of it. And then they're actually building that on CLIP pre-trained model. These are both that we discussed already. So VIT is a vision transformer, and CLIP is what that's actually being trained by having vision transformer as a backbone. And CLIP actually does this higher dimensional contrastive learning, where it does know how similar words and different images are matched in the higher dimensional vector space. And this is multimodal phase. So basically the pre-trained vision transformer encoder is then integrated with the decoder of Qwen-VL. So this way, what they're doing is they're doing this joint training phase. So basically, this is where the connection is happening. So this is where you're connecting with vision. I mean, this is all the pre-phase where you already have the pre-baked vision transformer, but they also made sure that they have variety of data. And here they're basically trying to connect that together, and so that the model can understand images and text together. And then they're also doing the long context piece. So it is just to process, understand sequence of information over long context. Maybe that's the reason why they are really good with understanding like videos as well. And they're also able to understand like complex scenarios. They're basically doing some kind of process to increase, basically to solve some problems like needle in the haystack, where you have a huge context and they're able to infer some data within that. And after that, you do, they also have like, I mean, the supervised fine tuning, and these are all they all follow this process later on. But yeah, this is one of the process in which you have you have a process where you're just doing the similar thing. And nowadays, you also see the supervised fine tuning. So after the model is created, now if you want some special skills the model needs, maybe you need a Qwen model that can not just see images, but also see maybe a specific scene. And it has to be really good at probably predicting like how close a car is to a van. Maybe just seeing the traffic scenario all day, you're just fine tuning it on different traffic. And you can even predict if there will be an accident or not, because you could use reinforcement learning to do that by having the model itself get trained on it. Because people are also doing reinforcement learning to have model do math. Maybe you could even train that to just show it a PDF file without doing an ACR, OCR. It can just see an equation and even calculate that equation within its embedding space. It's possible. It's possible that people are also doing it as of now. So that's the reason why you'd see a lot of GRPO and OCR training. That's all part of the super. This is all part of the fine tuning phase, but basic foundational wise, this is how you're training. Hopefully that makes sense now. Any questions in what I said? You can always ask. So VLMs are different than video generating models. Yes, Dishant. So VLMs are way different than video generating models. So video generating models are based on diffusion. They use something called diffusion transformers. That's a complete different thing where they start with a noise. It knows how to reduce noise to form something really meaningful. So VLMs are something that can just see the world and give you the output in the text space. There are some things which can also do in the audio output as well, but given an image, they can image and text. You could do either one of them. You can do an image or text, or you could just give a PDF file which has text in it, right? Convert that PDF into an image and give it to a VLM. It will give you an output, but the output will be in the text space. But it is not a video generating model. Video generating model comes into a different model architecture altogether. It's a different diffusion transformers, which does know how to iteratively clean up a noise to make it look something better. So that is different together. It's way different than VLM. Will you be running the models or your GPU? If not, could you please give a short intro on how to do it? So these models, how to do it, you could actually, what do you have? What machine do you have now? If you can share that machine, I can give you instructions on how to install Olama, and you could actually get it running, maybe a smaller VLM to run it locally on your machine. There are also some VLMs that you can actually run locally. Like this is a fast VLM from Apple. It's very straightforward. It doesn't take a lot of memory. You can even run them on a browser. I mean, honestly, there are people who even did that. You could actually run them on a browser, and I think there's a smaller version of this fast VLM. You could also programmatically, if you're a JavaScript developer, you can actually use fast VLM from transformer module. And then run it locally probably on your, it's called web GPU. It uses, so it can run on my, I know I don't think it will take my video because I'm already on video. Oh no, it can. So I don't know, it's static. Okay, yeah, there you go. It's describing me. So it's just not taking, it's just running on browser. So it's just giving me the description of what I'm doing now, just through the browser. So if you want to host it locally, you could just run this as well. And also there are other small VLMs that you can use. So if you can just share which machine you're using, we'll give you instructions on, and this is where you could actually use this ChatGPT provided output to install Olama to begin with, and then we'll talk about how we can run that locally. Sure, sounds good. Oh, I have i9 10 Gen and I run Olama locally. Why you're not able to, even with 20 GB RAM as well? What do you see an error, Ashan, when you do this? What is the error that you get? Did you install Olama? Ashan, can you hear me? Yes, okay, you install Olama. So when you run Olama, did you do a Olama pull? The next step is to use Olama pull command. Did you do that? Can you do this? Olama pull lava. Can you run that? Yes, I run on a Docker. Okay, you run on a Docker, but Olama is actually having Docker under the hood. So you are running that in a Docker means okay, you are running Olama in a Docker. Also have the Olama web. Okay, that's fine. But Olama, you could do okay. If you either one of them, right? It could either be Olama on the web or here. It's just the same thing. I have installed it headless, but you could also install that, from this as well. Um, you can even run it through web, but you don't have. Not sure how to run on GPU. Okay, so when you say you don't know how to run on GPU, what is the output that you get when you do Olama pull? But do you know how to use CLI from your machine? Okay, it's an Intel Mac. Gotcha. It doesn't. Okay, basically because of the 10th generation Intel i9, because it doesn't support. It's not here or there. You could do that. There might be not GPU support, like you might not a system on chip, unified GPU run, but still you could use some you could use a quantized model probably to run it, and there are some settings that you probably need to do for your machine. But if you want to do that, okay. I mean, if you want to speak out, you could speak out. It's not a problem, Asham. If you have any. Can you hear us?
Okay, so question was, I'm not quite sure how to run the panorama in GP. That's what. So I tried several articles and steps, but never able to get it through.
Are you talking? I could hear someone talking in far away, but not your voice. Maybe is it because of your headphones or something? Can you please talk again? I could hear someone talking, but not. Um, yeah. So if others want to try, please do try, and let me know. No, I cannot hear Ashana. Maybe you can reconnect your audio and get back to us. We'll help you out to run that.
Yeah. Can you hear me now?
Oh yeah, now we can hear you.
Okay, cool.
Awesome. That's
So
much better.
yeah, thank you. So the problem is I run Olama model on Docker, and I tried several uh, articles and steps to run it on GPU. So that's where I'm not following.
Okay.
Yeah. So is
Um,
it possible?
I mean, you could some quantized models. You can, because as of now, your Mac it doesn't have a metal backend for Olama, so that's the reason why you're just using CPU. Because all of the M1, M2, M3, they have a GPU and CPU together. They have a different architecture and they use metal backend. So I mean, when we are in Mac, you can't use NVIDIA, so you could only
Sorry,
use metal. Yeah,
I'm using an Intel
yeah.
i9.
Is it Mac or is it a
No,
CPU?
it's
Okay.
Intel. Sorry, I didn't
Okay,
mention
okay,
that.
okay, okay.
Yeah,
It's an Intel CPU that you're
yeah,
using. Okay,
yes.
and does it have a GPU as well?
I have a separate GPU. It's an NVIDIA 3090 Ti.
Okay, I mean you should be able to run. So do you have an exact error that you get when you're running it?
No, I don't have it right now.
But you could always do this whenever you're running. But you are
Mhm.
running that through a CLI, or you're running through are you
Uh,
running through maybe through a web or something like that? Are you using
CLI,
anything for
CLI.
CLI?
I ran several commands.
Yes, if you debug and whatever error that you get, if you can
Mhm.
share that in our meetup channel, I
Okay,
think someone would help you out with it. It
okay,
should you should be able to run it, but I mean I'm a did on the meetup. You could always ping me personally, or you can put it in the group.
okay.
We can help
Great.
you out.
Thank you.
Okay?
Thank you.
Yeah, no problem. Thank you. Um, And anyone who want to discuss anything, if you guys want to go ahead and start working on this simple Olama creation and or running Olama and running these VLMs, please do so as of now. Um, or any questions that you have that you want to share, or maybe anything that you are talking. Yes, Mark, it will be available. I'm live on YouTube as well, so this recording will be available on YouTube. Let me share the YouTube link, or maybe Sai, can you share the YouTube link?
Yeah, sure.
Yeah. Okay, so if you guys don't have any questions, we can at least talk about something. Do this small one identify multiple subjects confidently? If not, what size would you name? So, when you say subjects, yeah, I mean, it all depends on what is your image at hand, right? Uh, so it all depends on what even a smaller model could able to with fine tuning, you can make a smaller model also being more confident in a specific to detect a specific subject. But I don't know what is your problem at hand. I mean, are you trying to do classification? Are you trying to get any analysis on an image? So that really would be making a lot of difference. Yes, Vidal, we do have a YouTube channel. We have all of the previous meetup events, even the one that happened day before yesterday is there. So I think as soon as uh, Sai, he will share that link. Yeah, there you go. That's a live link, and that's where it's recorded. And you will also see a channel link there. That's Age University channel. So Dishan, do you want to talk to us on what thing that you what is the thing what are you trying to achieve? Okay, analysis of an image which says 7 people at a pub. I mean, you could do that. Um, you could do that even with a small model, maybe, right? Um, now let's say we have this. Um, I'll just go ahead and download this. And let's see if our model could just describe this. I'm using Lava model. It doesn't take a lot of resources. Oh, you want to count properly? Okay. So yeah, that is where I don't think counting will be a thing here. It's counting. I don't think the model would do good with counting. None of the models would do because see the problem with counting, but you could make a model count well by using RL, by using reinforcement learning. You could do that. Yes, Vidal, that's right, Age University. But you can't just have a given image and have it count. It might be correct, it might be wrong, because these models are trained with a lot of internet data, right? Just like you ask a model to generate something, it usually generates something that's already familiar with. Just similar to that, if you have an image and ask a model to count it, maybe not. Maybe it can detect that subjects, but counting is something that you can. It would be an emergent behavior that you can have. You can create that in a model by using the reinforcement learning. Um, and in that case, you probably need a lot of label data, and then well, not a lot. Even for less data, you can do that. So using GRPO, you could do that. So if you really want to do it, that would be a cool project if you want to take up and work on it. I mean, we can definitely help you out with how to do it, and just start working on it and see if it can do it. Because a lot of people did this previously, and even now, previous models cannot do arithmetic, but with RL, they are able to actually do math. So Gemini model seems to be a early fusion across long context video, while open source seems to be cross attention out of is the adaptive fusion good enough outside of the big cloud setting, like any estimate the accuracy we could achieve. Local camera security over land. Okay, so okay. Okay, the adaptive fusion good enough outside of okay, I mean It all depends on the model. Gemini, they have a lot of compute, right? They have so many GPUs. They could still do early fusion because it might make their environment more stable. Because when you do early fusion, when you're developing a model to understand the long video context, um, uh, the compute is not a problem, and it might work with it. But cross attention, because sometimes, if the compute is a problem, yeah, you have someone use that. So end of the day, it all depends on the foundational model developers on which architecture to use, and also based on their data sets that they have. And if and when you say video, they might have also used it to even analyze audio or even other modalities. So if that is the case, it's up to the foundational model creator, like why they use that. In terms of good enough, since it is an early fusion, as I said, early fusion can be good enough. Only problem is a computation, but because you're just concatenating and now you're trying to find the pattern, and also your model dimension. How deep is your transformer? Like how many layers? How many attention heads? How big is your how big is your training network? What is your context length? So all of these really matter in that decision, like either doing early fusion or doing a cross attention. Um, so in terms of the accuracy you can achieve, as I said, the accuracy of that, end of the day, it all depends on your data at hand. Like what do you want to do with that? Okay, maybe it's a local camera that you probably want to detect, or maybe it's a restaurant, right? Restaurant that is detecting. Maybe you want a restaurant setting where a camera just sees and see people doing certain things. Maybe you want to make sure that model the model can probably summarize all of the events that day that it has actually seen, maybe everything that happened throughout the day. It will probably summarize and give you the output. But the thing is, if you fine tune that model on that specific data a bit more, where you're just giving it examples and having proper fine tuning, then it can really do way better than Gemini as well. Like even if you're using a bigger model where you're probably sending each and every stream and asking Gemini what is it you're seeing, you could replace that with a smaller model. I mean, you could actually start with a Gemini model in the cloud setting. I mean, we don't, end of the day, for us, we don't mind, or we don't even care like what the model or what kind of architecture the model actually used. I mean, end of the day, bigger the model, the reasoning is really enhanced, because when the model is bigger, it is able to capture more patterns, and it can give proper reasoning. It can retrieve the proper subject. It can even describe an image way better. Like now you see this. There are some places where it is not able to like really give more in depth, but there are some images that it can even detect probably maybe an MRI. It can even detect cancer, future tumor areas where, say maybe some pixels would probably tell hedges where the cancer would occur. And people have actually built that because they fine-tuned it only for that domain by getting a lot of data set and then fine-tuning it. In your case, if it is camera, you could probably get a lot of this data from your camera itself, and then tag it, or even have Gemini tag it for you. And once you have this data set, now train a smaller model to do the same thing, and accuracy would probably eventually improve. So yeah, it all depends on your data set. Can you talk about some applications of VLM that people are successfully using for? I mean, there are a lot of applications that people are using, but it all depends on which application that you're talking about, right? There are people like Imagine, like, I mean, it's a very cool application. There's a app that actually tells people, like, it tells the customers how much tan they can have, how much time they can stand in sun to know how much tan, like, or maybe they see the tan level of their skin now, and then they suggest how long they have to be in the sun to get to that tan level, right? VLMs are also used now to various other things as well, but if you want, we can wait. And also most of the robotics, right? Most of the robotics eyes are actually VLMs. They are VLMs actually. Most of the they enable vision language action. So they have this foundational VLMs based on it.
Mommy,
Sorry, I could hear some.
Mommy, I need my iPad.
Let me mute. Okay, is it muted? Okay, I just muted. Okay, that's nice. So that's most of the robots. Like if they want to understand the world, they do use this. But their mapping is also action. But they do use vision language model just to understand. Okay, what's there? Is it a cup? What I can do with this cup, right? It can understand that. So they form the eyes of a robot. And okay, there you go. They say there are a lot of in medical diagnostics it is being used. I know, and autonomous systems, yeah, even like some Tesla cars, they are using VLMs now. Even though that's computer vision, and this is a finely tuned computer vision, but VLMs would even enhance that. I don't know if they have a new version that is updating, which might use VLMs because now they can even talk to you. Like maybe your Tesla could say, "What did you do all day? Like where did I drove?" And probably it can even chat with you because now it knows what it has seen, but now it can summarize that with you by mapping what it has seen into a language. Or even it could be a straight VLM that's just sitting out there and just seeing the world, and tomorrow it can chat with you, right? So yeah, it is possible. And a lot of autonomous systems, drones have VLMs. Some drones use VLMs to go out and like look for construction sites. Like I know some people use it in your Metas. I have that Meta as of now. When you go into use Meta Ray-Bans, they are able to see everything because of VLMs. They're using Llama VLMs. They're using probably Llama 3. And if you see the failure that happened that day, right? When you see the Meta ad, the Ray-Ban ad, it failed to tell where to start because the VLM is too small. It's not smart enough. And it happens a lot. I use Meta Ray-Ban. I've been using it for a year, and there are a lot of times where it doesn't understand a lot of things. I mean, as of now, it is not on device. Even it goes to the internet, it gets back the response from the internet. But even then, right, if you're not sitting on device, even if you're on the internet, sometimes they can do some mistakes. But yeah, it is being used there a lot as well, even in the small edge devices and cameras. And eventually, everything will be done through VLMs. I mean, VLMs are also used for computer use. If you know, most of the models, when they say, or most of these LLMs or model providers, they say, hey, my model can control your computer. They're able to do that because of VLMs. Because there's a VLM, or even the model natively can know the screen. It understands the screen. It knows where to click to do what. So that is what it's doing. It's able to predict the exact X path to click to perform the computer use. That's all powered by VLMs. Yeah, hopefully that answers your question. Yeah.
Hey, Raj. Yeah, thank you. Thank you very much.
No problem.
Yeah, I'm joining in from India very early in the morning for your session.
Oh, really?
Yeah.
Awesome.
I've been doing that for last 2 sessions.
Oh, really? That's nice. I
Yeah.
mean, I do have some sessions in India as well, but I think this series, I didn't start it, but I have Bengaluru Meetup Group and other groups that probably we will do eventually these sessions again there. But as of
do
now,
add me
I'm
to
in
that
the
if possible. I'm in Bangalore itself.
Oh, really? Yeah, I have a different group called Bengaluru AI group that can. I mean, we do.
Yeah, if you can
I mean,
share
I
the
haven't
link.
scheduled
So,
it. Yeah, it's the same. I don't know how you got hold of. I don't know which group you are in. Did you see
I
this in
don't
Luma?
know. I don't remember. But
Okay,
yeah.
you could join this meetup group. It's Bengaluru Meetup
Cool.
Group, and we have like 7,000 people there. Like I do
Oh,
regular
great.
events.
I do
we've been
that.
doing this for almost a few years. Yeah.
Yeah.
So these
I
are
just had one question.
Yeah, go ahead.
Another one.
Yeah.
So these like how much of the capability of the LLM is retained in a same sized VLM?
Okay.
Like
That's definitely it's a good problem as well. Like most of them are trying to solve. So imagine there's an LLM that does really good reasoning, but now you add the vision capabilities to it. Usually, when you train an LLM with very good reasoning, but now you're also adding a multimodal capability to it. So it might lose some kind of reasoning that it already has. Like it might be way better just being an LLM with proper reasoning, but now you add a vision capability or using a vision backend and you train it using that backend, it might lose it might not perform really well in the language modality, but it can perform well in both modalities together, but it might lose, if you go and evaluate or see the benchmarking, it might lose that capabilities a lot. So that's a problem that's happening for a while. But only thing which really stood out with me is the Qwen model, which is the Omni model that just came out, Qwen-3 Omni. They are the ones who just found a way to stop having that, right? It's called Qwen-3 Omni model. So now they are training this Qwen-3 Omni model across. If you see that they're using image, they're using language, they're using they have image, language, audio, all of them, but it is not losing any of its capabilities in other domains. Rather, it is just doing way better in all of them. It's even meeting benchmarks in all of the other other modalities as well. Like if you see here, it is able to beat like 32 benchmarks and 22 across 36 audio and audiovisual benchmarks. So they were able to do that by changing the model capability. I mean, they are using something called thinker and talker. I might have to go through this a bit more because I haven't read this completely, but I'm working on this thinker and talker architecture and how they did it. But it would be a great way for you to review this if you really want to understand under the hood what's going on. But yeah, that's a good question, and it might not retain all of its capabilities as before. It might lose some capabilities when you add a different modality to it.
So just on a follow-up on that, can it at least evaluate its own answer, whether it was a good answer or not, and then we can maybe use, or maybe we can use an external model to augment that answer, maybe something like, for vision capabilities, we can have a VLM, and we can route maybe the language capabilities to another model. Like we can kind of having a router in the middle. I don't know. I mean, just thinking.
That's what happens within it, right? When you see mixture of experts, that is what's happening within it. So
yeah, I was also thinking probably it is built on some MOE.
Mixture of experts. Yeah, MOE. MOE is what it is built on, because that's where, that's the reason why, you have some experts which are only good at like vision task. And it has a router too. That is what mixture of experts is. So if you see a mixture of experts, but it is not happening in a level, it is happening a level which is inside the model. It's happening within its latent space. But what you're talking about is probably in the higher level, maybe in the network level, right? Because now you have a router and now you're sending one to a VLM and a LLM and now a VLM, because that would probably incur a lot of latencies, cost, because now you have to host two different models, compute will increase, latencies will increase and all. So this architecture, MOE architecture, they create different experts. They all sit here, and this is what the router is. It's a gating network. So every input that is given, you forward that input across different experts. So it is not a very dense feed-forward network. So when you do a transformer, there are different feed-forward networks which are really dense. So they divided that. They divided that into different experts, so that each expert, which is these are learned. I mean, when I say expert, they just learn that parameter. These experts are just blob of numbers. They are not actually really experts, which are one. They're just blob of numbers, but they're learning some parts of the embeddings really well. And when you're trying to do inference, they are really doing really great with it. So if you see the Qwen model, whenever you see a model name like this, let me show you the name of this model so that you know. I mean, how they notate the notation, right? How I don't know where they notated this, but let me do this. Qwen. So if you see this notation here, it says Qwen Omni 30 billion and active is 3 billion. So when they say active is 3 billion, so 3 billion is nothing but the same thought process, but it is happening within that format where only 3 billion is the expert. That only 3 billion is the expert. So in 30 billion, if 3 billion is like 10 experts, there are 10 experts. Each expert is doing something, right? Same thing happens here. So, but it is happening in the model level. So that is what it is. MOE thinker and MOE talker. They are different small networks or small experts which are learning something from either audio space a bit better, and they're also learning something from the language better. That's the reason why this model is actually doing really well, and the benchmarks are also not really compromise here because of this architecture, which is mixture of experts architecture.
Okay. So, do we have any intuition on like these mixture of experts, whether they are uh, parallel layers, and some of them are only some of the layers are only active at for any particular inference, or it is just random, what do you
Mhm.
say, layers
Yeah.
which get activated and there are no layer concept. You understand my question, right?
Yes. Yeah. So basically, yeah, I understood your question. So it is random. So the router that you're talking about, it learns based on your input. It learns which expert it has to send that input to. If it is
So
getting tokens which
when it
are,
is
yeah.
sorry, so when it is you're
Go.
saying expert, there
Yes.
has to be some what do you say, access to an expert, right? I mean, how do you access or how do you send? Is it that it randomly sends to some neurons
Hmm.
which it knows?
Yes.
Okay, or is it,
Yes.
or it sends to a certain particular set of neurons? Okay, yeah, I think it's
Yeah, I
the
mean, yeah,
same
that is
thing
what
in
it,
a way. Yeah,
yeah, it does the same thing. It learns all of that through during training because during training you
yeah.
have forward pass and backward pass. So when it is doing it, it randomly set up an expert and now it does a backward backprop and it learns, okay, if that is giving a proper output or not. Now it again sent to a different network. So they're doing that in a different way.
Basically the router is learning that which by passing to which neurons do I get the right output, so it keeps that information probably.
I'm sorry, what was that? Can you please repeat that? I missed that.
No, I'm saying the router eventually is probably learning
Yes,
which neurons to pass a particular query to get the right output, particular kind of
yes.
query to get the right output. Yeah.
Yes. That is what is running, right? Because when you do the training process, each and every expert learns something new, and we don't know what it learned. So it could be learning some vision, some this of language tokens. It might be learning a bit of audio tokens. So we don't know exactly what it is learning because these are all like numbers, like it's all matrices that's solving. So it eventually it might learn. Some networks might be learning something, and some networks might be learning some characters. So that's the reason why they do that is, you're not, if it is a huge model, you're again creating some kind of diversity within the network, right? When you do that, when your network is a bit more complicated, when they have more they have different networks, then you're capturing more patterns. That's what's going on here. So eventually you might not know which router is good with what aspects, but it's up to the router that decides. Maybe these experts are good with probably Japanese. Maybe that is what they're observing. Like when they run the model, there are only few networks that get triggered, that get activated because during the training process, maybe those really learned Japanese really well, and those experts are really. That's the reason there's no proper name for that each expert. You can't say, oh, this is the expert because, or maybe it may not just run a bit of Japanese and a bit of audio as well, maybe a bit of video too. So that is what's that really makes them really diverse, and it's all happening late in space. So yeah, definitely interpretability is always a black box. We don't know exactly what's going on under the hood.
Yeah. Thank you, Raj. Looking
No
forward to your
problem.
great sessions.
Absolutely.
Yeah.
Thanks a lot for joining from India. I know that it's really late for you. Yeah, thank you. That's great. Sure. I mean, anyone has any more questions we can discuss? Okay, I'm surprised how well Lava is working CLI. Any tips or recommendation on the UI? Do you run this in CLI? I usually use CLI, but you could even run through UI. I think it should have a way to run it through UI as well. I know I've installed like 2 different versions of Olama. Okay. I don't know if I'm reinstalling. Yeah, maybe I'm reinstalling this again. But yeah, Olama, I usually run it through this. Does this come with a web as well, Olama web? Maybe web actually runs in a web UI, right? It opens up in a specific UI. So maybe I can serve. When I do a serve, it will show up in this. Let me check. How can I serve this? Okay, run Lava. Okay, I can go into this and check. Okay, Olama is running, but can I get into the Lava model from here?
Hey,
don't know if
Raj,
I can.
there's an Olama web UI application is separate.
Okay.
Yeah, that's what I have been using when you asked me whether
Okay.
I was using CLI. So
Okay.
web UI is separate, I believe.
Okay.
Yeah.
Okay. Yes, if you have it, probably we can. So are you able to run it or no with WebUI?
I believe the question is not to me, right?
Oh, is it you? Okay, I'm
No.
sorry. Who was asking? Drew. Drew was asking it. Yeah, I'm sorry. I think it was you. But yeah, thanks for throwing it out there. I didn't knew that there was a web UI because I don't use web UI a lot, but it should be running from there as well. I believe so in the web UI because web UI is probably just UI for this.
Yeah, because
So
I'm not good at CLI. That's why I was
okay, I
using
mean,
it.
yeah, same thing here.
Yeah.
I mean, I usually do everything from CLI, but yeah, maybe a lot of them don't really like CLI. Maybe check with this. I'm just running web UI to check how it works, and then we'll run it and see. So Drew, do you have any problem there when you're running it in a web UI? You're not able to run it or something?
Hey Raj, I just have one more question.
Yes.
Like, which are the good remote? I think Qwen you mentioned is an open source one, right? Which are the closed source VLMs, which are good, right? Like maybe Gemini, right? 2.5 Pro and all that, correct?
Yes.
So, is our question was like, is the cost different than language models generally for multimodal or this kind of input?
Um, Multi-language input, the cost, yeah, maybe the cost will be different because the images, right, depending on your quality, if it's like 1090, 1080, or maybe the how quality your images that count to be higher tokens. So more than language, images more tokens because images, if it is really high quality image, then probably each patch would be containing a lot of data. So you might exhaust a lot of your tokens by sending this to VLM. I'm sorry, a closed
Yeah, so
source model.
I was
Yeah.
just thinking that, I mean, in this, in a language, you generate more tokens, right? Eventually. So your
Yes.
input and output tokens both are getting increasing, like,
Yes.
eventually. But here, I think we are having a fixed set of tokens, right, for an image. And the output will not be that huge generally, if we are talking about a simple description. So I was just
Are
thinking
you?
out loud. I don't know. I mean, inside maybe it is more compute intensive, or
Yes, it is.
I don't
It
know.
is
I think it. I
complementary.
don't know even if I even don't think it is compute intensive because ultimately it is using the same architecture, right? Which is matrix multiplication and things like that, right? There is no image we are doing separately. Whatever we are doing with text, we are doing the same thing with image. Maybe a little bit different, but why should there be a uh, costlier? I'm just trying to understand mechanism.
Okay, you're saying that probably a image speak more than a bunch of text, and image should probably be a more denser representation of information, and that might cost us less. Is that what you're saying?
Yeah. I was thinking it might cost less eventually. I just because it's a fixed set of tokens, right? Generally.
Yes, but if you're sending images, as I said, if you're sending like maybe images from a high quality video, then it might exhaust your token. So you probably need to do a resizing. You should make sure that how much you're sending. So you could have trade-offs in what quality of image that you're sending into the model. And less quality means probably it's less cost, but also you might lose some information as well. But yeah, it's all about the trade-off. But I would recommend like Qwen would be way cheaper. Like I know it's open source. And when you're using Qwen model, it should be great. It should be doing way better than like even other models. Like, I mean, yeah, Claude and all, probably they might be doing a lot more. They are trained on a lot of data. Even with imagine like someone need to talk to Claude or maybe describe something. Let's say if I want to describe all my application workflow, if you can just upload the diagram rather than uploading maybe 2 pages, it should work, right? Because now a diagram even has like a small workflow. It's as equivalent as it's equivalent to images. So that's what I'm saying. So yeah, it's all about trade-off. Like it all depends on how much quality you have and also how much information you're putting into that image. If you want to convert that image into a text and then do the reasoning in the text space, or you just want to do everything in the image space, you could do that. Yeah. So those are some of the, some of my insights.
Yeah, makes sense.
At the end of the day, it all depends on what use
also.
case. Yeah, you need to test out and see and how much savings that you have with it. Oh, so Purva, I mean, we don't have nothing to discuss apart from this. So the essential takeaways are, I mean, if you want to work on this hands-on, just Ollama is really good to just get your hands, working with these VLMs. But in part of the overall session, I have covered most of it in terms of like fundamentals, right? I mean, I haven't covered everything, but at least fundamentals in terms of vision and vision transformers, how CLIP and how this entire field evolved from CNN and all the way till here. So that's the reason why I went into questions. But yeah, I can just say I can say that it's almost done. Like most of the I'm done with all the slides. Only thing that's remaining would be is some key takeaways is probably I want to do this is, we know that VLMs, they fuse different representations to generate text from images. You do have all of these are open models, SmolVLM, MiniCPM, or Qwen 2.5VL. These are all really small models that you can run on any GPU. And with Ollama, or even if you want to host it to like a bunch of them, you can host it using VLLM. And if you are, if you want to learn a bit of VLLM, we already had a session day before yesterday. You can always refer to that on YouTube, how to use VLLM to serve something in production. And the task that these VLMs could serve is VQA, which is visual question answering, giving a vision and asking it to answer some questions on that, like where this person's sitting, how, or maybe what, maybe you can't ask how many people are in the image. Maybe it's not really good with counting. I think we already discussed that. Retrieval is really important. So maybe, you already know if you're using iPhone or anything, or you could always check with the retrieval part, like you go and chat in the, in your, I forgot the name of that. Maybe in iPhone, you can actually check if you have thousands of images in your iPhone. You don't have to go through, like, maybe you went to, you visited Fiji or Hawaii. You could just type in Hawaii. You could probably retrieve all of the Hawaii pictures because now it knows it can retrieve that. It's a small vision language model that is running in your iPhone. It's a 3 billion parameter model that's actually running. So you could do retrieval as well. If you're doing RAG, we will have a session on this coming Tuesday. We could also do that. Localization and document parsing, also some of the use cases where we can use a VLM. So a lot of people, I know some people are using VLMs to find fraud documents, like tweak documents, some documents which are different. Maybe someone really messed with it, including, some government fabricated documents as well, because I have some startup that I'm a mentor for in Charlotte, and they do use that for document parsing. And Ollama is something that is really useful to run on locally. You could run these models, and then the future you'll probably see a lot of dynamic resolution, long video reasoning, and agentic capabilities. These are some things that probably will be baked into the model going forward. That is what we're seeing as a trend, right? Going forward, as we start from the beginning to now, every year, like and 2 years ago when I started doing meetups, I always say, hey, models cannot reason. You probably need to create agents to do the reasoning. And then models started baking reasoning into them. So now the models can do reasoning, and they can also do, recently Claude Code, they have agentic capabilities already inbuilt, like Claude Code SDK, or Claude recently released an agent SDK, which has a lot of things the model itself could do. So these behaviors are actually getting into the model better and better. So tomorrow we might have a small VLM. It cannot just generalize to detecting what subject is it, but it can also give better insights than a human eye could do. So we can even have, you can even just see a textbook and even do that calculation mentally and give you an output. So it doesn't have to, you don't have to do an OCR, you don't have to have other things. It just analyzes even the videos too. Like you can see the videos and get information. As of now, most of our internet world is only text-based. If you really want agents to even watch videos and come back and even do reasoning in the video domain, it's possible now. I think there's some startup doing already. They call it VideoDB, which I haven't research what they do capability, but they actually do extract information from videos, long reasoning videos. Agentic capability is also something that we might see in the next coming VLMs. So yeah, I think these are the key takeaways. But if you have any questions, please do reach out to us on Meetup group, or we do have a in a Meetup group. You can always message and have someone, and even on LinkedIn, we are active on LinkedIn and Instagram, other places. So wherever you can definitely reach out to us. So hopefully, Purva, I'm not to work on fine tuning. No, we're not doing any fine tuning of VLMs. I'm sorry, Purva. I don't know if you had any, but we could do that fine tuning using this collab notebook. But I was not trying to do this in this session because this would again add a bit more to, because I wanted this to be more of a one-on-one session. But you could feel free to do this. If you want to go ahead and work on this collab, you could always do this. If you are stuck somewhere, Unsloth has the best models or best notebooks that can teach you how to do fine tuning. But we did had previous sessions on how to do fine tuning, small language model fine tuning. I don't know if the survey that I sent before, it might giving you a wrong impression that this fine tuning session. But we do have in YouTube, we do have sessions on fine tuning that you can go back and refer to. If you go to our channel, yeah, I think this is one of the things, and even the live sessions, we do have previous live sessions that was, yeah, this is the one. This is called fine tuning small language model fine tuning of this. So you could refer to this, but it is not the VLMs, but these are just a fine tuning of small language models. Even there, I'm actually going through a small these VLMs book as well. But yeah, VLMs fine tuning could be a great session. Probably I'll plan for it sometime next, maybe sometime this month or next month, because yeah, we are doing events like every week. So probably we'll do that. Next events, I'm also planning for reinforcement learning for agent improvement. So not just fine tuning, but also we're doing reinforcement learning, fine tuning of how we can make our agents perform way better. Thanks. I don't want you to be late for your meeting, but yeah, thanks. I think this you got the gist of it. Thanks a lot for joining this call. Can you mention open model summarize videos without accompanying transcripts or captioning? Yes, it can do just summarization without having any transcripts or captioning, because if you have and Qwen can do that really well. I mean, if you go into Qwen models, they can do that. I mean, we can just test it out their website. We can give an input of a video model and ask it to summarize. I think it can do way better. I'm not sure if they have access to, yeah, it's a bigger model. Like, I don't know if you can access this YouTube video, or if I have a, or you can just go ahead and ask it to do. I'm not sure if it can access, because here the search capabilities are disabled, does not support web search. But in here, you can come here and just upload a video and have it. Sorry, I don't have. Okay, maybe I have this. Okay, let me just go ahead and ask you to summarize my video. It's a video which I created for code world model work that Meta did. So let's see what it does. So I'm just uploading it, just 170p. So in this model, it doesn't have to do any transcript or anything. It just sees the video and gives you an output, and it's really fast too. So let's see. It's kind of a lengthy video, but let's see if it can summarize. It's still loading. So once it loaded, we can ask this question. Okay, there might be a network error, but let me go ahead and try it again. It might be a bigger video. Maybe it's not able to get all of that, but yeah. So Drew, I don't know if you was able to get this up and running, but I haven't tried a UI yet. Do you run this in CLI? But you could even run that in the web. The Olama UI is what I'm learning. I don't know if you're using Docker to run it, but if you're stuck somewhere, please do reach out to us on the Meetup group. We can always help you out. We might create a Discord channel pretty soon, or even a Slack, maybe a Discord channel pretty soon, so that you can ask us those videos or all of these questions for you to work on that. Our community members can help you out. Are there any other videos with me? Okay. I don't know if I see that is a smaller video. I could upload that and check. What is this? I'm not sure what is that. Okay, there you go. So it's working on the summarization of my video. It's 5 minutes long video, not too long video. So it doesn't have any transcript. It's just trying to summarize it. No, Drew, I think Qwen 2.5 is way bigger. So you could also try like SmolVLM. SmolVLM could be even a better model, even fast VLM or SmolVLM. I think the links, can you share the links with Drew, the SmolVLM one? Okay. It is, yeah, it's able to summarize my video. I mean, it's not able to summarize the text or the audio because I think this is not an Omni model. It doesn't understand what I said, but it's just able to give you what it is. Like, he's wearing a green t-shirt, he's positioned in front of a plain white wall, background, what's there? There's a frame painting. There's also some, black arm is visible, the camera remains completely stationary. So it's basically doing this. But in terms of summarization, without any transcripts, you could always use the Omni model. It can actually do the summarization as well. So if I do the video, I'm not sure it can directly take the video or not, but it should able to even understand the image. Yeah, it's exceeding 150 megabits. But yeah, so the Omni model could actually do that. Without any audio, it can actually do that specific thing. Hopefully I was able to answer that. It was able to do the description, but open summarize videos without a complete transcripts and captioning. Yeah, it could do that. And just explain what's going on in that video. As of now, that video, what I'm doing is just a talk on some research paper, so it's not able to, but if I probably do actions, maybe if I have the same video of someone moving or maybe it's a video of a dynamic environment, like something going on in the road, then yeah, probably it can describe all of it without any captioning or transcripts. If it is audio, yeah, it can even take audio as an input, but here the Qwen is complaining that my video is long. So if you have a smaller video, you can always do that. Sure. Drew, I think Lava, since it's been a smaller model I've used, but SmolVLM is something that you could give it a try and check what is there. I'm also looking at this Olama web UI. Somehow it's not working my local. Yeah, it just says can't be reached. Maybe I don't know. It's just maybe some issue with this, but oh, come on. I think I did not expose this. I did not expose this Docker container in my, I was multitasking and I was not able to do the exposing of this into my local. So that's the reason it's not running. So I had to do a port mapping of this. So I'll come here, do -t, and I think it's 8080. Okay, there you go. Okay, I think it's Olama Web UI. I did not sign up for this, but do you think I have to sign up to get this? Okay, maybe I could. Okay, there you go. So, okay, so Olama Web UI, and you can come here and look for different models. I can select a model. Okay, there you go. It's actually pulling all the models which I have locally. That's nice. And then I could just use this and ask questions here. Okay. 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 The lava model. So yeah, it's running on this. And oh, you got prompts. You also can use model files. Yeah, it just looks like Open Web UI. I think there's also a product called Open Web UI. It almost looks like they forked that and created this. That's how it looks like. Yeah. So Drew, what is that you're not able to do here? Like you could come here in case you want to install something in this. I'm not sure how you could install a model. Let's say if I want to add a model, it's just select a model. But if I want to download a model, I'm just checking how you could do that. Pull a model from Olama. Okay, now you could pull a model from here. You were you able to do this? You could come here and just enter the model name that you want to pull, and then it will go ahead and pull it. It's also able to pull like Mistral 7B. I just click on it. Okay, to know what models are available, you can come here and enter the models that you want. Maybe if you want to download Gemma 3. And if you see, if you go into all of these models, every model has different versions. If you see here, it had 270 million, 1 billion, 4 billion. So you can check any model that you want. So you can you come here and probably you want to download, maybe it's Lava or even SmolVLM you want to download. So SmolVLM is really small. You have multiple versions of SmolVLM. So if you come here and click this, it only has like 500 million parameters. You could just, it's very simple to install. It's a very small model. So you could just click on this, or maybe all you have to do is get this name and come here and do this and download, and it's just pulling the model. So after you pull the model, now you can just go and chat with it. Hopefully you're able to follow along with this, Drew. If you have any questions, please do ask. So now it's able to download. Okay, there you go. The model is downloaded. So I come here, check for SmolVLM, and ask it to
Excuse me, Raj.
Yes, Drew. Oh, I don't know who I'm talking
Ashan.
to. Ishan, yeah, go ahead. Ishan.
Yeah. So my question is around this. So when you downloaded the model, right? So what I'm trying to do is can we run that model on the GPU? That's the question I asked earlier.
Yes, you can run this model on the GPU too. But in your case, you probably need to set, because you have NVIDIA GPUs, right?
Yeah.
So you could run that Olama on GPU, but
Okay.
it should detect that automatically and run it. If you have any problem, you can always ask ChatGPT
Yeah. Okay.
to
Yeah.
guide you. But
Yeah.
I want to know the exact error because sometimes misconfiguration do occur. So how
Okay.
comfortable are you in using CLIs and all of this? Like, did you ever work with this previous systems?
I have, but I always prefer GUIs.
GUIs. Okay, yeah.
Yeah.
If you want
That's
to do
fine.
GUI, yeah, you could do this, right? Ollama is very good. You could probably
Yeah.
do this GUI. In that case, only thing you have to take care of is you need to do a Docker run. But even there, probably you could.
Yeah.
Okay, all you have to do is install Docker. In Docker, you can just pull once you install Docker desktop, you could come here and select Ollama Web UI,
Okay.
and then yeah, Ollama Web UI. I think it should be Ollama Web UI. Yeah, there you go. This is the one. So you just pull this image. I can show you this command. Yeah, this is a command. Use this command. Okay, it says Rico Web UI. I don't know what is this.
That's fine. You can
Yeah.
continue with what you did
Yeah.
earlier. I
Yes.
just yeah.
Yeah. In model parameters, thanks by the way. Okay, yeah, in model parameters. So like what's the further I can go? So what limits will I face at 36? So you have 36 GB on Mac M4, so you do have good resources. So you could experiment with Qwen model. So go with Qwen. Qwen-VL, maybe a 7 billion or even 3 billion parameter fits, but 3 billion you can't use it commercially, but 7 billion you can. So you can use that and experiment with it. So you could install Qwen models. I would recommend Qwen for you, Drew. Yeah, sounds great. Thank you. Okay, so sounds great. It was a great session. I will go ahead and stop my screen share. But if you guys have any questions or anything like that, please do forward us in our meetup group. You could follow me on LinkedIn. I just share some news and all of those, and also you could even follow Agentversity. We are here for upskilling. We are about to start certain programs for anyone to be upskilled, anyone who wants to upskill. So it's my LinkedIn, and also I'll send you Agentversity LinkedIn page. And we do conduct all these sessions for free. Anyone who wants to educate, we do educate for free. But if in case going forward, we might use some AI agents and all to train and upskill everyone using Agentversity. So that makes us stand out with other edtechs. Is we are trying to make everything AI native. So we are trying to build AI agents which can help someone upskill really fast. Stay tuned for those, our platform and all of those. Maybe sometime in this month, we will come up with all of our platform features that can help someone upskill really fast. So yeah, there you go. Oh, Dishant, I'm really sorry. I can follow you. I mean, you can follow me, and only reason is I cannot accept connections because I mean, it's not that I'm against it, but only problem is when I accept a connection. Everyone has their interest, right? Some might be previously when I accept connections, you probably see a lot of probably anything with you are into AI, yeah, that's fine. But there are some connections which come, and the feed is something which I'm really curious. I learn a lot from LinkedIn, so I usually follow or connect, mainly follow people to learn AI or Gen AI. So if I can't connect with you, please don't mind. But you could always follow me, and I'll follow you. So yeah, please don't mind if I don't connect. But yeah, I think. But if you have sent it earlier, Dishant, I'll connect with you now because I know because sometimes I can't judge who is who. So that's the reason why. But yeah, let me accept that now. Okay, sounds great. I'll go ahead and stop this. We can come back. We'll have a different session on multimodal RAG this Tuesday. Please do sign up for that on Luma. If you're on Luma, please do that. We are trying to get off Meetup and get into Luma. So please do subscribe to